Okay, so hopefully you've done all of these yourself and you're just coming here to look for the answers. The first one, I'm going from a haloalkane to an aldehyde. Again, you can't do that in one step, so I need to ask myself, if I wanted to get to an aldehyde, how do I usually make aldehydes? I usually make them, always make them, come at them from an alcohol. Can I get from a haloalkane to an alcohol? Yes, you can. So to get from a haloalkane to an alcohol, you're going to react your haloalkane with NaOH, and that's going to give you an alcohol. And to get from the alcohol to the aldehyde, you are going to oxidize it using K2Cr2O7 and H2SO4. Okay. The next one, you are going from an alkene to a ketone. Okay. Again, we've spoken about this. How do we get to a ketone? We always come at it from an alcohol. So you need to convert your alkene to an alcohol and then from the alcohol to the ketone. How do I convert my alkene to an alcohol? I need to add water across the double bond. That's going to be H2O as a gas. And I'm going to do that in the presence of phosphoric acid. When I do that, I'm going to have, and again, it's important that you put your OH group in the right place. So I'm adding H2O across the double bond. I need an oxygen on this carbon, so I'm going to put the OH here and the hydrogen will go there. Then I'm simply oxidizing this with acidified potassium dichromate to get my ketone. If I look at C, I'm going from a ketone to a haloalkane. Again, easiest thing to do is go via your alcohol. Okay, if I go from a ketone to an alcohol, I need to reduce it back to a secondary alcohol. The reducing agent we use is sodium borohydride. Now that's not on your chart because we don't technically come across it until year 13, but it's just handy to know. You can oxidize an alcohol to a ketone. You can then reduce a ketone back to an alcohol, and the reducing agent is sodium borohydride. So you reduce it back to an alcohol, and then it's just a straight substitution reaction to go from the alcohol to the haloalkane. You will get this from your chart. You're going to use NaCl, and you're going to use H2SO4. The next one, you have got a carboxylic acid and you're converting that into an alkene. When you look at the two molecules, they do actually look massively different. This one looks a lot smaller, but if you look more closely, you'll see that it does have 3 carbons and 3 carbons, and all that's changing is the carboxylic acid group going to an alkene. If you want to go from a carboxylic acid group to an alkene, you are again going to go via an alcohol. So I'm going to reduce this back to a primary alcohol, the whole way back to a primary alcohol. Again, I'm going to use my sodium borohydride. Actually, do you know what? Sodium borohydride won't work on that. You'll have to use a lithium aluminium hydride. It's a stronger reducing agent. We haven't done this yet, apologies. Okay, but to go from carboxylic acid back to a primary alcohol, you're going to use lithium aluminium hydride, LiAlH4. Once I've got my primary alcohol, I just need to dehydrate it in order to make it an alkene. And to do that, I'm going to use concentrated H2SO4. So when I dehydrate it, I'm going to lose this OH, and I'm going to lose this hydrogen, and I'm going to form a double bond here to give me my alkene. Next up, I have got alcohol, and I'm going from an alcohol to an alkane. If you want to go from an alcohol to an alkane, you're going to need to get rid of that OH. So the only way we have come at alkanes is from alkenes. So you're going to go from an alcohol to an alkene, and then an alkene to an alkane. How do I go from an alcohol to an alkene? I need to dehydrate it. And if I'm dehydrating it, I had it just here, I'm using concentrated H2SO4. I dehydrate it, I end up with an alkene. Alkene to alkane is just hydrogen with a nickel catalyst. The last one, go from carboxylic acid to a haloalkane. Again, there's that reagent that I haven't actually taught you, LiAlH4, lithium aluminium hydride. It just reduces the carboxylic acid the whole way back to your primary alcohol. And once you've got your primary alcohol, it's just going to be a substitution you're going to use NaCl and H2SO4 to substitute your chlorine in for your OH. Okay, so for each one I needed the intermediate and I needed the reagents for the first step and for the second step. Summary questions, you can get these answers at the back of the book, but I'll just fly through them really quickly now. Functional groups, this should be straightforward. You have got an aldehyde here, you've got an alkene here, you've got an alcohol here. So there are your three: aldehyde, alkene, alcohol. In this one, you've only got two. You have got a carboxylic acid and you have got an alcohol. The reagents conditions required for 2-chloropropane from propan-2-ol. So I'm starting with propan-2-ol and I'm going to chloropropane. Okay, it's a substitution reaction. To do it, you need your NaCl and H2SO4, and it also asks you for the conditions, and the conditions are going to be reflux. So if you're asked for conditions, make sure you're mentioning if it's distillation or reflux. In this case, it's going to be reflux. Two different synthetic routes. You're trying to go from an alkene to an alcohol. If you flick back to your chart, you will see that if you want to make an alcohol, you can either go directly from the alkene to the alcohol by just adding steam in the presence of a catalyst, or you can go from an alkene to a haloalkane, and then from a haloalkane back to the alcohol. So there's two different ways that you can come at this. If I'm starting with butene, so there's my there's my butene. I want to go into butan-2-ol, which is going to be butan-2-ol. I can just, sorry, you can't see that. I can just add H2O gas in the form of steam and phosphoric acid, and I'm going to go from my alkene to my alcohol. The other way I can go is starting with my alkene. I can react it with sodium chloride. This is going to be, sorry, that's not what I'm doing. I'm starting with my alkene and I'm reacting it with hydrogen chloride, and I don't need any catalyst or conditions, and I turn it into a haloalkane. And once I've got it as a haloalkane, then I'm using my sodium hydroxide and I'm using reflux, and I'm converting it into my alcohol. So there's two different methods. One is straight from the alkene to the alcohol. The other, you go alkene, haloalkane, alcohol. Last question. Sorry, this is going to be small. Reaction one. You've got two functional groups, I think, in each molecule. In reaction one, that should be a CH2, not a CH3. You're going from an alkene to an alcohol. So you're obviously adding water across that double bond. So it's going to be H2O in the form of steam. So it's a gas with phosphoric acid catalyst. The next one, you're adding bromine across the double bond. You're losing the double bond, you're adding bromine across it, and you're also substituting out your OH for bromine. So in order to do that, sorry, it's really hard to see. In order to do that, you are going to use hydrogen bromide. So just using hydrogen bromide, it will add across the double bond and you'll get a substitution reaction. And then the last one, all you're doing is changing the alkene to an alkane. To do that, you're using hydrogen and you're using a nickel catalyst. I'm going to be online on Teams, so just message me with any problems that you have. If I've gone really quickly through something that you're finding difficult, please talk to me about it. It's really, really important that you ask me questions about anything that you don't understand. Or if you spotted any errors that I may have made, again, you can totally put me up on it. It's very, very possible that I've made a mistake someplace.